Hi, welcome to week 8 of Discrete Math. In this video, I'm going to give you the brief general overview of our next upcoming homework. So for homework 8, we're moving on to chapter 2 of our textbook, which will be talking about sets. All right. So before we go on further, I just want to make a small note on the notation. So in the past, I've had some students were confused about the notation between the subset of, which is this, and versus the proper subset of. So feel free to read through. I think I got this example. I think it summarizes pretty nicely. But while you guys can do that at your own time, while pausing the video, I can also give you guys a separate example. We can say that, let's say set A is all even numbers. Okay, and I can say that my set B contains the numbers 2, 4, and 6. And I can finally come up with another set that says this is 2, 3, 4, 6. So in this case, I can say that set B is a proper subset of A. Set A, since, I think by definition, if X is in B, then that same number X is also in A. So to give you a proper definition of a proper subset is it's a subset that is not identical to the original set, but it must contain fewer elements. So that's why we're talking about the number of elements in A is less than number of elements in D. So for example here, the number of elements in A is 1, 2, 3. There are 3 of them. And number of elements in D is 1, 2, 3, 4, 5 of them. 5 and 6, sorry. There's another one. Okay. So we can say that B is a proper subset of A. We can also say that B is also a proper subset of C. Okay. So aside from the differences, we're not gonna necessarily get into the details of which is which. If you just have the general understanding of what a subset is, then unless we get to the number of the elements inside, which is in another chapter, you shouldn't be too worried which this symbol versus this. Okay, so I think I assigned number 4 as our homework. So I want to go over number 3, which is very similar. So 4 was homework. Okay, so let's go over 3. So we're given 2 sets. The first claims that a set of airline flights from New York to New Delhi. So I'm going to call this as my set A. Or we can say this is the first subset since it's given in the problem. And the set of non-stop airline flights from New York to New Delhi, this is of course our second set. All right, so in this case, I would say that our second subset set is a subset of the first because those non-stop flights are one of the many kinds that includes are part of all the flights that goes from New York to New Delhi. So this is true for A, but at the same time, this is not necessarily true. The other way is not really true. Okay? Because if we say that a set of airline flights from New York to New Delhi, this would only be true if there only exists non-stop airline flights. But I'm assuming there we can take multiple stops to get to New York to get to New Delhi from New York. let's talk about B, a set of people who speak English and a set of people who speak Chinese. So really just interpreting as the language itself, this will be neither. Because we're saying a set of people who speak English, and we're only assuming that they only speak English, and the second set would be the people who speak Chinese. So in the Venn diagram, we would have this as the English people, and this is Chinese-speaking people. Okay, so this would be the case where this is true. Neither is a subset of the other. Part C, the set of flying squirrels, the set of living creatures that can fly. So obviously, the living creatures that can fly is a bigger Venn diagram. So if I draw it, this is our second set, which is the living creatures that can fly. And the flying squirrels, this is our first set, will be part of all the living creatures that can fly. So we would say that first is a subset of the second set. Okay, we can't really say the other way, which means that I can't say that second is a subset of the first. This is not true. All right, so for the next problem, I assigned number 7 as homework, so I would like to go over 8. So for each of the sets in exercise 7, determine whether this is an element of the set. So I want to make sure that you guys know the difference. Determine whether number 2 is an element. We actually have to see if that actual 2 is part of the set. And you have to understand that 2 is different from the set of 2. This really is saying the box that contains 2. So maybe it could be the Amazon box. Inside of it, it must contain 2. And this is just 2 itself. Okay? This is also different from this. So 2 is boxed 2 times. So having 2 boxes, and inside of the 2 boxes having that 2 is different from having 1 box and not having the box at all, just the number 2 itself. Okay? So speaking in that sense, this is not an integer. This is just a set of 2. This is a box of 2 containing inside of it. So therefore, A is false. Okay? B, because A only really includes the integer greater than 1. So I guess for the answer for 7, this would be true because just the number 2 itself is an integer greater than 1. B would also be false because if you're talking about a box that contains 2, can't really tell. I mean, it's not even an integer, so can't even tell if it will be a square of an integer or not. So this is false. C, it does contain that the set of 2. So this is true. Likewise for D is also going to be true. And because it also contains that. This one. Okay. And for E is going to be, it's going to be true because it contains that 2, the box of 2. And lastly for F, this is going to be false because it contains the set of the 2. Okay, so let me just read out. C was true, D was also true, E was true, and F was false. Okay. All right, so 32 is assigned next. Let me just do one of the 4 parts. So let's go over A. So this is not our usual multiplication when it comes to sets, that it includes all possible variations or combinations of the sets A, B, and C. Okay? So for A, B, and C, this will be, I can include this in a big set, and this will contain the values that I'll have. First, let me go with A, so it's going to A, and from B, I'll take the first element 2, which is X, and from C, I'll also take the first element, which is 0. So that's a possible combination. The order does matter, which is A times B times C, or the other ones, as you'll see. Okay. And now I'm still running on my first A, so I have to use up all the possibilities. So I'm going to do A, and I've used, let me use X, because I still have this one that I did not use for the last set. And you're just continuing to list out all the possible mix of the elements of the set to create new subsets. So I'm still going to take A. The next value is going to be, it looks like I used up all my X with the choices of the C. So now I'm going to go ahead and use Y. And for C, we can use 0. And I can keep going, Y, comma, 1. All right. So it looks like I used up all the combinations that starts with A, then with X and Y, and likewise for the C. Now I'm going to move on to B, and doing the same thing all over. So B, comma, X, comma, 0, B, comma, X, comma, 1, and B, comma, Y, comma, 0, B, comma, Y, comma, 1. All right, and I'm just going to list out the last choices, possible answers using C. And there we go. That was my answer for part A. I'll leave the parts B, C, and D up to you guys. For cases like D, it's probably best if you just write out B 3 times. And so what I mean by is X, Y, X, Y, like this, and find all the combinations. So the idea of this kind of leads to the next problem, which is find A squared. So as long as you remember A squared is A times A, and this can be written as a set of A of 0, 1, 3 by 0, 1, and 3. Like that, and finding out all the combinations is what you have to do to find A squared. So to get you guys started, it would be looking something like the values of 0, 0, and also 0, 1, 0, 3, and also now moving on to 1, 0, 1, 1, 1, 3, and so on. Okay. Okay, and I'll leave you guys to finish part A and also get part B done.